Hello. I've got here a short little demo of confidence intervals that will help you as you're trying to understand effect size a little bit better. So I hope you take a few minutes to watch this. I've already solved this problem, but here it is. A researcher tested the hypothesis that students who meditated before taking a test would have higher IQ scores than students in general. You can see this is a one sample t-test because we have the need to compare these students who meditate with the general population, for which we know mu, but we don't know sigma. So we'll estimate sigma from our sample. We're given the information mu equals 100, sum of squares equals 3780, and we're testing the hypothesis of alpha as 0.05. And you can see here that I've already done the calculations. I've already worked out the spread. I've listed everything in here. Mu is 100. Standard deviation for the distribution of means is 3. It's a normal t distribution. We're stated to use alpha equals 0.05. And I have gone ahead and used the calculator tool to find out what the T alpha cutoff point is. I've calculated the sample score and I've made a decision. So to place these decisions within the framework of our image, this is where the understanding is with confidence intervals. So first of all, let's make sure I have my black pen here. First of all, this is what we typically do. We find our cutoff point, 1.72, place it. We write T alpha equals 1.72. We shade the tail of the distribution, indicating that this is our reject region. And we place our sample t-score. And in this case, our sample t-score is 2, so it's placed right here. So t-sample equals 2.00. Of course, that falls within our shaded region, which means that we reject the null hypothesis, and then we have the concluding statement stated. So now let's remember something about this image that we draw. First off, this refers to what we used to call population 2, but which I think it's actually better to call population 0 because it represents the null hypothesis, the general population where there's no impact of the treatment. And so if we think about it that way, then we can translate these z-scores back into raw scores. So remember, this is a distribution that has a mean of 100. I'll just show you, show you right up here. So this distribution is the distribution of means, okay, not the distribution of individuals. And this distribution of means that we use for our statistical test has a mean of 0. And then we look at SM, the standard deviation of the distribution of means, when we talk about this actual distribution we're using to compare. And so in this case, we had mu equals 100. We didn't use sigma because we had to estimate it. So we use SM, that equaled 3. So if we were going to go back and talk about the raw scores that we used for this distribution, you'll remember this from chapter 2, I believe. We just line these up, adding the 6, adding the standard deviation. And make sure, yep, the standard deviation is 3. And so that's what this distribution looks like. This is the null distribution. And if our sample score fell in this reject region, we'd be saying our sample's no different from this general population. But we did find, in fact, that our sample score was significantly different. We had a t-sample of 2.00. That was our sample score. So what we do to think about a confidence interval is we think about, okay, this was the mean, the 2.00 was the mean for our sample. What does that translate to then? The actual mean score for our sample was 106. And so let's translate this into raw scores. This was 106. I'll write it down here. 106. We still have the same standard deviation. We still have SM equals 3, but now we're drawing a picture of our new population, the population represented by those students who meditated. And so this is now what this distribution looks like. So you'll know always when we've been doing these statistical problems, we've been comparing two populations, population 1 and in the past population 2. Now we talk about that as population 0. We've been comparing them. But we actually have two, so this is actually population 1. We did draw a sample out of that group. We did find a mean for those students who meditated. But remember, it represents a population, not just that one sample. And so that's what we often forget when we're doing statistics. We think that we're talking about comparing this group, this little sample that we drew, to do it how your book usually does it, to compare the mean of that group with population 1. And that is indeed what we're doing, but this is intended to represent a different population. This null population on the left with the research population on the right, and that research population, population 1, also has a distribution. So maybe our sample, assuming that it was indeed a reasonable sample, it could have been anywhere in here and still been a significant result. And so we figure out what we can ascertain about this. And so we figure out a 95% confidence interval, say, which would allow us to say with 95% confidence where the true sample mean would fall. So we'll call it the 95% CI. It's a pretty straightforward process within the Z distribution or the T distribution. We just look up the two-tailed cutoff points. For whatever, either 95%, then we look up alpha equals 0.05. Or if we're talking about 99%, we look up alpha equals 0.01. I'm going to show the 0.05 here. So we look up the two-tailed cutoff. In this case, T alpha. And we just plot those points. We can plot. We don't always have to. And then we can calculate the raw scores, the raw means for the T cutoff points. So let's go ahead and do that. If we look up the cutoff points for that sample, we can use this new tool that I think is a better one because it has many distributions. We can enter 0.05 for the 95% confidence interval. And our degrees of freedom in this case, oh boy, I better double check because now I've forgotten. Our degrees of freedom were, let me just drag this away and double check. I think it's 19. Our degrees of freedom were 20. Okay, I'm glad I double checked that. So let's go ahead and enter that 20. Hit calculate. And we can see our two-tailed critical value is 2.086, plus or minus 2.086. So we can go ahead and push that onto our, I did already mark it here. I see it rounded itself, 2.086. And that's our 0.05 cutoff. So we can draw those then, but we draw it on our sample distribution because now we're saying this represents distribution 2. So 2.086 would fall right around here. I'm going to get my black out here. Okay, I'm going to try to get my black out here. There we go. All right, so 2.086 and minus 2.086. So these are the T alpha equals 2.086. And down here, 2.086. And so now what we're saying in this case is that we are 95% confident that the true mean for population 1, for our treatment population, falls within this center region. So what is this stating something about? It's stating about our level of confidence. So I'll type up that statement in terms of what we can actually say about this confidence interval. So first off, our confidence interval, we need to calculate, in order to know this, we have to go back and calculate our raw scores. So confidence interval calculation is simply the sample mean plus the cutoff point, T alpha, times the standard deviation for the distribution of means. So that's our formula. Let's do a quick calculation on the lower end. So I should say that for the upper interval, we add the mean. For the lower interval, we subtract the mean. So let's go ahead and do it here. You can see I've already calculated, but I'll redo the formula. Equals the sample mean. Let's zoom over that way. And let's just do that little calculation. This, let's do a minus first for the lower interval. And this little calculation, let's find the 0.05 cutoff that we just looked up and multiply it times our spread for this distribution of means, and we get that lower interval. And for the upper interval, we'll do the very same thing. You can see I did it backwards there. It doesn't really matter, order of operations, equals the sample mean plus that 0.05 cutoff times SM. And that brings us to the upper confidence intervals. So let's just shorten those up and take it as 97.5 and 114.5. We can say our 95% CI is 95.5 to, or we can just put a dash, 114.5. And how do we interpret it? This is really important and a little bit picky in terms of appropriate interpretation. We can say we are 95% confident that the true, remember our type 1 to type 2 error. Right now we're talking about the true population mean, true population. True mean for population 1, our treatment population, falls between 95.5 and 114.5. So we can use that word confident because it just states like kind of how confident we are. It's like an emotional state, but we wouldn't be able to say something like this. Let's write out down an alternative. We couldn't say something like there is a 95% probability. And it seems really picky with the language. But if you think about it, probabilities are something that can be calculated, and confidence is just like a level of trust that we have. So we can't actually say that there's a 95% probability that it's going to fall there because it's just one of many sample means. And so if we were drawing this interval around a different sample mean that we happen to draw, it would look different. So we can't really state anything about probability. And we also can't say something like this, we are confident that 95% of the sample means will fall within these intervals. We also know that we can't have that confidence because once again, we're building this around a mean that we don't know. And we want to make sure that when we state our confidence, we state that we're confident about the mean for population 1, that treatment population, not the null population. So this is all about the treatment population and what we believe to be true about it. So just keep that in mind. So this is just defining a level of confidence that we have about the true mean for our treatment population. So I hope this was helpful. You're going to have a couple of practice quizzes. One of the practice quizzes asks you to calculate the confidence intervals, and you will have to use the degrees of freedom to look them up. And the other one asks you to select the statement that's the correct interpretation. So hopefully those will all be very clear to you, and I'll cut this video short for now so that you can not be stuck in too long of a video.